Now, this is Data Analysis 1. My name is Roland, and we continue with Chapter 2 this time. So, Chapter 2 we started, and we finished before the 4 levels of data. So, let's look at, just in a summary, what we have learned. Structured versus unstructured data, quantitative versus qualitative data, and then we looked at these terminology. So structured organized data means that the observations are in a way formulated that resembles to rows and columns. So rows and columns shape. And unstructured data, which is actually like 90% of the data, is in the form of, free form. That means like videos or text or posts. That doesn't follow any standard organization hierarchy. Most of the data, as I mentioned, is unstructured, whereas scientific observations, as recorded by careful scientists, is usually structured data. Okay, so structured data is generally thought of as being much easier to work with and analyze as well. What else? Well, example of data processing we have run through as well. Let's see. Here we go. So word phrase count, then the existence of certain characters, special characters, the relative length of text, and the picking out of topics. So these things. And here we have a tweet, and from a tweet we can start the word count, and we move forward each level. So then presence of certain special characters, and then the relative length as well, which is the length of the tweet divided by the average length, and then picking out the topic, which is not general. So we find the topic from the sentence, and then we moved towards a quantitative and qualitative data. So what is the difference between quantitative and qualitative data? Well, quantitative data, the data can be described using numbers, and basic mathematical procedures can be operated. So basic mathematical operations can be conducted. Qualitative data cannot be described by numbers and basic mathematics, but usually by text, so using natural categories as language. Here is an example for that, the coffee shop data, and we see already here as well. So the name of a coffee shop, here I don't have it. So the name of a coffee shop is going to be a qualitative data, since it's text. The revenue can be added up, so it's a quantitative data. The zip code, well, it's number, but it cannot be added up, so it's a qualitative data. The average customer number can be added up, so it's a quantitative data. And the last one here, country of the coffee origin, so it cannot be added up, it's qualitative. Now, if you have a problem to decide between qualitative or quantitative data, then the best way is that you ask some basic questions. For example, can you describe it using by numbers? No? Then it's already qualitative. Yes? Then move to the next question, and the next question is about does it make sense if you add up the values, the numbers? If no, then it's qualitative. So, for example, the zip code. If yes, then it should be quantitative. And here we go. Define some questions. What is the average value? And for qualitative column, which value occurs the most and the least, and so forth and so forth. Good. We have an example here at drinking examples. So the alcohol consumption data from WHO, and we used to check out the columns as well. So what kind of data we have here? So the country itself is obviously a qualitative data. Beer serving, spirit serving, wine serving, and the total of all alcohol consumption is obviously quantitative because we can add them up, and the continent itself is again qualitative. Now, we checked what kind of statistics we can get in Python for it, and I actually also checked in R additionally. Also, we have to differentiate between discrete data and continuous data. Now, discrete data is the data that can be counted. So 1, 2, 3. So for example, how many times do you go home? How many times do you go shopping within a week? All right. Continuous data, well, this describes the data which is measured. Like speed, okay, or your height can be measured, right? Okay, and now we just arrived to the 4 levels of data which we have to talk about. Let's start. Okay, so the 4 levels of data, why are these so important? Now, it's generally understood as a specific characteristics of structured data can be broken down into 4 levels of data. You see it here, gradually more structure, which means also more returns from analyzers. Now, the nominal level is the first level of data, the ordinal level is the second one, and we continue with the interval level, and we arrive to the ratio level. What are the differences? Well, let's see that. The first level of data, as I mentioned, is the nominal level. It consists of data that is described purely by name or category. Basic examples are gender, nationality, like that. And then they are not described by numbers and are therefore, of course, qualitative. So a few examples are still here. You see that the type of animal or a part of speech is considered as nominal level of data. Now, of course, we cannot perform any mathematical operations on nominal level of data except the basic equality and a set membership. Now, what are these? So, being a tech entrepreneur is the same as being in the tech industry, but not vice versa. And a figure described as a square falls under the description of being rectangle, but not vice versa. A good question is, what is the measure of center? So here we go. What is it? A measure of center is a number that describes, and here we go, that describes what the data tends to. Measure of center, what the data tends to. What the data tends to. It is sometimes referred to the balance as the balance point of data. So data tends to is the measure of center, or it can call also the balance point of data. Here we go. What are the examples for that? Mean, median, and mode. In order to find the center of nominal data, we generally turn to the mode, so the most common element of data set. Now here is the most common element of data set is actually, we don't have it here. So the most common one is the continent of Africa, making that the possible choice for the center of the continent column. Now let's move to the next level as well soon. Okay, what data is like at the nominal level? Data at the nominal level is mostly categorical. So categorical data, because we generally can use words to describe data, and it can lost in translation among countries, or even can be misspelled. But let's go to the second one. So here we go, the ordinal level. The second level is, as I mentioned, the ordinal level. So the ordinal level once we have finished with the nominal level, we can continue with the ordinal level. Data in ordinal level provides us with a rank order, or the means to place one observation before the other. Now, however, it doesn't provide us with relative differences between observations. That means that while we may order the observations from the first to the last, we cannot add or subtract them to get any real meaning. Here is an example for the Likert chart, which we know, the Likert scale, which means that we can rate, for example, the satisfaction from 1 to 10, and 8 is usually better than 7, while 3 could be worse than 9. However, differences between the numbers do not really make sense here. The difference between a 7 and 6 might be different than the difference between 2 and 1. The mathematical operations which are allowed, as we mentioned, ranking, so ordering, and the comparison. Now, ordering refers to the natural order provided to us by the data, but this can be changed as well if we would like to. So, for example, here is an example: color range. We start the colors with red, or we continue with orange, then yellow, green, blue, indigo blue, and then violet. We can accept it naturally, but what if somebody else thinks, okay, this order is there, but I would like to get it in a different way? So comparisons are another new operations which is allowed at the ordinal level. It would not make sense to say that one country was naturally better than another one, or that one part of a speech is worse than another one. At the ordinary level, so ordinal level, we can make these comparisons. For example, we can talk about how putting a 7 on a survey is worse than putting a 10. let's also talk about the measure of center this time. At the ordinal level, we can of course talk about the mode, but now the median is usually the appropriate way of finding a center of data. The mean, however, would be impossible because division is not yet allowed at this level. Imagine you have conducted a survey among your employees asking how happy are you with your working here. So scale it up from 1 to 5. And these are the results, right? And then you use the numpy, so the numbers in Python, and you can get them. If you sort the levels, you can get the mean, but it is not really correct here, right? As I mentioned, because the mean doesn't show actually what we need. NumPy median shows something more related to that what we want. So the median is what we can use here. What we also can get here is that the median is not only more sound but makes the survey result looks also much better. Let's look at it again for a moment. So here you see it's 4 4 4. So okay, nominal versus ordinal level. So let's see the differences. The origin of the beans in your cup. Yeah. So what this is, that's obviously nominal, right? The place someone receives after completing a food race is an ordinal one. Ranking, as I mentioned, order, data, ordering. The medal used to make a medal that they receive after placing in the race. It's not about the ranking here, it is about the medal here. So obviously it would be which one? Nominal. The telephone number of a client, again, this is nominal. We cannot add, we cannot actually we can compare. So let's say we can compare the two telephone numbers. In that way, it's an ordinal level. And how many cups of coffee you drink in a day? Well, you can add them up. So I think we can also go to the next level this time, and that's the interval level. At the interval level, we are beginning to look at data that can be expressed through very quantifiable means and where much more complicated mathematical formulas are allowed. The basic difference between the ordinal level and the interval level is, well, the difference. The data at the interval level allows meaningful subtraction between data points. So for example, temperatures. And you see here for, in the book, Fahrenheit temperature, what we use, Celsius temperature. Now you can also compare them, right? In Orlando, let's say it's like 30 degree, and in Seoul it's like 15 degree. And then it seems as though the example in ordinal level fits the bill of the interval level. However, remember that the difference between the scores does not make sense. Therefore, this data cannot be called as interval level. Now, here, as I mentioned, it can be basically it can make a right sense if we talk about the temperature. Let's also get the mathematical operations first before we continue with the measures of center. So what we can do here is equality set membership as from the nominal one, then the ordinal one, ordering and comparison, and now we can add addition and subtraction. The allowance of these two operations allow us to talk about the data at this level in a very new way. At this level, we can use the median, the mode from nominal, median from ordinal level, and to describe this data. And now we can add also the arithmetic mean, or simply just said the mean. Please recall the definition of the mean that requires us to add together all the measurements. At the previous levels, addition was meaningless, and therefore the mean would have lost extreme value. It is only at the interval level and above that we can make sense of arithmetic means. So let's also look at an example if we have here. Okay, here you have the example, and I also will make that example clear. Okay, let's see. Import p, and then we can continue with creating our list, and then we can print and numpy means, and we can also get here the median immediately, so print, and you see numpy, median, and temps. Let's run it and let's see the results here. So this is it. You could also add here the mean of temperatures is, and the median of temperatures is. So to make or more precise expression, you would do it in this kind of way. You see that now what it does. Okay, and then note that the median and the mean and the median are quite close to each other, and both are around 31 degrees. The question on average, how cold is the fridge? About 31. However, the vaccine comes with a warning: do not keep this vaccine at the temperature under 29 degrees. And I mean this 29 degrees obviously in Fahrenheit again. Okay, now measures of variation. This is something new that we haven't yet discussed, and it is one thing to talk about the center of the data, but in data science it is also very important to mention how the data is spread out. So spread out. The measures that describe this phenomenon are measures of variation. You have likely heard about standard deviation and variance. This idea is extremely important, and we will talk about it soon. Along with the measure of center, a measure of variation can almost entirely describe dataset with only two numbers. So we talk about the standard deviation and we talk about the variance. Now, here we have the code, which we will also create it immediately. So let's try to run it again. Okay, here we go. Okay, so the standard deviation is the most common measure of variation of data at the interval level and also beyond. The standard deviation can be thought of as the average distance a data point is at from the mean. While this description is technically and mathematically sort of incorrect, it is a good way to think about it in that way. The formula that's to do the following steps to get the standard deviation is like this. Find the mean of the data for each number in dataset, subtract it from the mean, and then square it. Find the average of each square difference and take the square root of the number obtained in before, and that would be the standard deviation. So once again, find the mean of the data for each number in the data set, subtract it from the mean and square it, and then find the average of each square difference, and then take the square root of the number obtained before when you averaged each square difference. Okay, so we got the mean. What we need to do is just get it done as a variable. Then squared differences. So we create an empty list and then we run for loop with the following expression. The difference is temperature minus mean, and then we square this difference. So square, and then squared differences append square, so we add each time the element or square difference to the list. This is the for loop, then average squared difference is num p mean squared differences. So this is now going to be the variance, and then standard deviation is equal num pi, and not the square root, the variance, and print again. Oops. the standard deviation. Let's run it. So we got again the standard deviation and the variance. All of this code led to us find out the standard deviation of the data set, which is around 2.5, meaning that on average a data point is 2.5 degrees off from the average temperature of around 31 degrees, meaning that the temperature could likely dip below 29 degree again in the near future. Well, also let's take a kind of look at this data. And before we do this, let's also look at it what we have done earlier. So let's also just run this one. So this was from earlier from the other class before, and I run it also now this time in R. You see, this is the way how I create my vector of numbers. Then I sort it. I don't need anything else, but I could do it. Then the next one is sorted results. I printed it out, and then I use the mean and the median. Now, without the sentence part, we don't need the paste. So, for example, if I just want to get the median, then all I need is this one here, and done. So, and now I can run this. All right, and we get also 4 again. Obviously, I did it as to get a full sentence, and I'm happy or more happy with that than just having a number 4 there. Good. Now, as I mentioned, we are supposed to continue this with our work. So this is no longer, we don't do it only in Python, but we work also in R. And you see the difference how fast it goes in R actually. So the temperature I can get from the book immediately. So C, and let's see where the book data is. So here is it. And the hard brackets I have to get rid of because they are not belonging into our vector. Then I can get the mean easily in R. You remember that here, right? So all I need to do is just copy paste here, change the so here temps, and here also temps, and mean temps. So temperatures, if you like. Then you can also go with the median in that way. Paste median of temps, and here also temps, and we are done. So let's try to run this part this time. Now the difference is also here. If I just select these 3 lines, I'm not going to run anything else. Okay, so let's take a look at here. You see that I created the means here and the median here, and I didn't run the above text. That's very important in R. And now we can get the variance also in the same way actually. So this is the variance of temps, so, and that's VER temps, and the standard deviation is going to be just SD. Of temps. Okay, let's select these and we can run it immediately. You see that the variance is 6.78, and standard deviation is 2.6. Okay, I think we can continue with the presentation again. And one thing I wanted to add to this topic this time, in the future, try to not only focus on Python but also work with R, just as I did it this time. As you see, there is a huge advantage of R, of using R. The reason is you don't need to do mathematical calculations to get the variance. You don't need to do any mathematical calculation to get the standard deviation. So please go ahead and also try every other examples using R. Now we nearly finished with this topic. So let's finish it with the last level, the ratio level. After moving through 3 different levels with different levels of allowed mathematical operations, the ratio level proves to be the strongest of the 4. Not only can we define order and difference, the ratio level allows us to multiply and divide as well. This might seem like not much to make a fuss over, but it changes almost everything about the way we viewed data so far. Now, examples. While Fahrenheit and Celsius are stuck in the interval level, the Kelvin scale of temperature boosts a natural 0. The measurement 0 Kelvin literally means absence of heat. It is non-arbitrary starting 0. We can actually scientifically say that 200 Kelvin is twice as much heat as 100 Kelvin. Then money in the bank is at the ratio level. You can have no money in the bank, and it makes sense that 200,000 is twice as much as $100,000. Measures of the center. The arithmetic mean still holds meaning at this level, but we can add here the geometric mean. This measure is generally not used as much even at the ratio level, but it's worth mentioning. It is the square root of the product of all values. So if we would like to calculate it, this is the way how we should calculate it. So let's also look at that here. Now, temps we have, number of items we need in the temps list, then product is equal 1, 0. So we create a float number for temperature in temps, product times temperature, and geometric means is the product powered by number of the items, so product by number of the items. But this product, you see that this is something else. That's why we use 1 point here. to get back to the original, to the global product here, because it's actually updated here, right? So print geometric means that would be the code. However, the code here we have is this. All right, let's try to run it, and we get the geometric means as well. So it's 30 point something. Note again how it is close to the arithmetic mean, and the median as calculated before. So the mean of temperatures and the median is here, and you see this is now the geometric mean. This is not always the case, and will be then handled in the future by us. And we can talk about the problems also in the ratio level. So there we go. Now, even with all these added functionality at this level, we must generally also make a very large assumption that actually makes the ratio level a bit restrictive. Data at the ratio level is usually non-negative. So for this reason alone, many data scientists prefer the interval level to the ratio level. The reason for this restrictive property is because if we allow negative values, the ratio might not always make a sense. Bank loan, for example, here we go. If we have a balance of 50,000, the following ratio would make no sense at all. If you take a bank loan of 50,000, so it's going to be -1. The data in the eye of the beholder, it is possible to impose a structure on data. For example, while I said that you technically cannot use a mean for the 1 to 5 data at the level of ordinal levels or ordinal scale, many statisticians would not have a problem using this number as a descriptor of the data set. The level at which you are interpreting data is a huge assumption that should be made at the very beginning of any analysis. So all the assumptions you must declare at the very beginning. If you're looking at the data that is generally thought of at the ordinal level and apply tools such as arithmetic means or standard deviation, then there might be a problem. We actually finished with this topic. So here are some questions. Whenever you face new data set, then take these 3 questions with you. So, is the data organized or unorganized? For example, the data does our data exist in a nice, clean row column structure? Then, is each column quantitative or qualitative? And for example, are the values numbers, strings, or do they represent quantities? At the level of the data of at what level of the data is each column? Now, for example, we mentioned these 4, so nominal, ordinal, interval, or ratio levels. The answers to these questions will not only impact your knowledge of the data at the end, but will also dictate and tell you the next steps, what you need to do in your data analysis. They will exactly explain the types of graphs you are about to use and how you interpret them in your upcoming data models. Sometimes we will have to convert from one level to another in order to gain more perspectives. But this we will talk about later. Thank you very much for your attention, and don't forget, please let me know if you have any question. Have a good time and enjoy programming with data analysis in mind.